Alright, good morning guys. So, last class, it's been a while since I've seen you guys with how last week was a B week, but we finished up with our limits unit, so we are completely done with that stuff. Nothing else we do is going to be calculus based the rest of the semester. In fact, the next big thing that we are trying to work up towards is reviewing and going more in depth than you had to in Algebra 2 with logarithms. But before we do that, we need to do exponentials, and before we do that, we need to do inverse functions. So it'll seem kind of unrelated at this point, but we're going to just do a quick one day on inverse functions, which is what you guys picked up this morning, number 79. And honestly, this is all stuff you should have heard from Algebra 2, but of course there's always a chance you forgot some of it. But this morning we're going to take some notes here. So let me try to remind you of the stuff that you should know, help fill in the gaps of what maybe you didn't forgot or you didn't learn in Algebra 2. And then the second handout is not exactly like what the quiz will look like, but we're going to use it as a practice quiz. So I'll give you 10 or 15 minutes to try it before we go over it. So it'll be a pretty short lesson today. Again, I hope that most of this is familiar to you to make it easy, but if it's not, then it's just stuff that you need to know anyway. Okay, so if you're given a function and asked to find the inverse of it, it's a two-step process. You need to switch or swap the input, which is usually x, with the output, which is usually y. Now, we even did a little bit of inverse stuff last semester with trigonometry. None of that stuff that we did do you have to remember for this lesson, though. It's just that when we did it with trig, the input was theta and the output was a ratio, an angle and a ratio. So when you switch that, that's when you get an inverse function. After you switch x and y, then you want to solve for your new y. And then we'll label it with this notation. So the function would just be f of x. If you put this little symbol there that looks like a -1 exponent, that means inverse. It's not really a -1 exponent, but that's the way it's written. Okay, so an example of that, if I wanted to know the inverse of y equals 2x plus 1, step 1, swap the input and the output. Step 2, solve for y. So undo plus 1, undo times 2. And then I don't know if I call this a third step, but you do need to relabel this. Since f of x does mean y can't be 2x plus 1 and x minus 1 over 2. Those aren't the same thing, so we shouldn't use the same variable. So instead of saying y equals in the end, we should say the inverse of f. So, not a terribly hard process because it's so quick. But switch what is the input with the output, solve for the new y, and then use the notation to indicate that it is the inverse. Okay, we also like to know if two functions are actually inverses of each other. So we're going to talk about it from an algebraic standpoint and from a graphing standpoint. Algebraic is the only one that proves or verifies that two functions are inverses of each other, though. So if you are asked to prove that they're inverses, like let's say f and g, you would need to plug g into f, and you need to plug f into g, and if they're really inverses of each other, both of these will simplify to just be x. It's called the composition of functions when you plug a function into the other one. But the only way to prove that two functions are inverses is to plug them into each other, simplify, and show that it simplifies to x. So on the very next question, we know these two are inverses because we worked it out up there just a second ago. This is the one we started with, and this was its inverse. But if you were asked to prove or verify, then one time you need to plug all of this stuff in over here. Everywhere there's an x, you're going to plug it in. And then the other time, you need to take all of this and plug it in over here. So everywhere there's an x, you're going to put a 2x plus 1. You need to simplify each one. So times 2 divided by 2 cancels, plus 1 minus 1 cancels, plus 1 minus 1 cancels, times 2 divided by 2 cancels. And since both of those directions simplify to x, we are 100% sure that those are really inverses of each other. That's the only way to prove it. Okay. Now, if you're interested, if two functions are inverses of each other, but you don't actually have to prove it, so like maybe this would be good for ACT when you have a limited number of choices, you should know what two inverse functions look like graphically. To do that, you would just go ahead and graph both equations, graph the function, and graph the one you think is its inverse. And if they are really inverses of each other, there will be a line of symmetry at y equals x. So again, this doesn't really work. This isn't good enough for a proof or good enough to verify, but it is a very quick way to just kind of eyeball and see if they're really inverses of each other. So for example, let's say on the ACT, this shouldn't say verify because this isn't really verifying. But let's say they give you this function and they say which one of the following is the inverse of it, and maybe this is choice A. Well, in your calculator you could have it graph y equals 2x plus 1, which of course has a y-intercept of 1 and a slope of 2. And then you can have your graph this, and I'm going to split this up, split apart my fraction so I can see the y-intercept and the slope a little bit better. A y-intercept of negative 1/2 and a slope of 1/2. And I usually just go ahead and graph the line y equals x also. So y equals x is the graph where all the points, the x value and the y value, are equal. So to be a line of symmetry, it should be cutting your overall graph in half, which this one is. If I flipped this black line, which was f of x, over my red line, it would land on my purple line. Or if I took my purple line and flipped it over my red line, it would land on the black line. Cuts my overall graph in half. So why I say this about the ACT, if this was a choice and you graphed it and it looked like there's a line of symmetry of y equals x, that's probably your inverse. That would be a quick way to know. But the reason why it's not good enough for a proof is one of these could just be a tiny bit off, where it kind of looks like it's a line of symmetry, but you know, very, 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 very small difference. One's just slightly tilted off. Okay, and then finally, we need to remember what the vertical line test, the horizontal line test is, and what it means to be one-to-one. I think we talked about one-to-one last semester, I'm not sure, but we need to write that in just in case. So if something passes a vertical line test, that's how you know it's really a function. So like y equals x squared is a function from the vertical line test, because any vertical line I draw hits the graph at most once. Whereas if I try to do the same thing here, the horizontal line test, this one fails the horizontal line test, tells you if a function's inverse is a function. Sorry, the wording there is a little bit weird. So if a function passes the horizontal line test, you know that his inverse is also a function. So again, not that you need to remember this, but if you remember when we did the trig inverse functions last semester, it's one of the harder things that we did. Part of it was because you had to memorize a bunch of ranges, and the reason why we had restricted ranges is because we had to restrict the domains, and the reason why we had to restrict the domains is we had to make sure that this stuff was true to be sure that the inverse was a function and not just a relation. So to be one-to-one, this is a very common term. We'll throw it at you, but also I know this comes up on the ACT. It has to pass the vertical line test, so it's got to be a function, and it's got to pass the horizontal line test. So that is inverse is a function. So like x squared is a function, but it's not one-to-one. Okay, and then kind of saying the same thing in a slightly different way before we move on and give you a chance to try the other questions to see how much of it you remember and get right without any more studying, is understanding how points on a function and its inverse relate to each other. So let's say, let's just make up like 4 points. Maybe like 0, 0, 1, 2, -2, 3, -4, 1. If I know those points about a function, you should be able to give me some points on his inverse. Because all it means to be an inverse function is that you're swapping input and output. So if you switch 0, 0, it's going to stay 0, 0. But 1, 2 is going to become 2, 1. -2, 3 becomes 3, -2. Swap input with output. And just to show you that it works that way, if I was to plot these points very roughly, there's f of x. If I plot his inverse, and this will not look perfect because my graph is so I may not have connected them in the same order though. I'm not plotting them in the same order. But what I was going to show you is that you should have a line of symmetry at y equals x, but I'm messing that up somewhere. But that's just kind of reinforcing it anyway. Okay, and then the last piece here that will come up is you need to be sure that you understand that if you are switching possible x's with possible y's and possible y's with possible x's, that means the domain of the function becomes the range of the inverse. Notice these values were the domain, and then they became the range. And the range of the function becomes the domain of the inverse. Range became domain. Possible y's became possible x's. Just one of the things that happens when you switch those around. Okay, so just real quickly, anything from the notes that I went over too quickly, you don't remember, sounds completely unfamiliar to you, anything you want me to talk about again? Okay. Then let me give you about 10-15 minutes, and I'd like you to try the other handout, and I would like you to treat this like a practice quiz. So see what you can do without looking at your notes, without a calculator, just see how much of it is stuck from that short little reminder, and then that will help you highlight what it is you actually need to look over again before our quiz. Let's give everybody about 5 more minutes and then we'll go over it. So do your best to be done in 5 minutes, please. been 15 minutes, so let's go over it, see how you did. Make sure there's not certain things that you need to look at a little bit more, and of course help you identify what you might need to review right before the quiz. So again, just to be clear, our quiz is at the start of next class, very short and sweet. Okay, so given these points, you should be able to give the points that would be on the inverse. So I don't know why there's so many points, but all inverse means is you're switching input and output, swapping X and Y. So that should be your answer for question 1. Question 2, verify that these two are inverses of each other, and it even tells you to use composition of functions, although we shouldn't need to tell you that, or even tell you this or this, but it's still the same thing. The only way to verify or prove that these are inverses is you need to plug one of them into the other one and the other direction. It is required that you do both, and then simplify. Multiply everything by 4. Oops. And do plus 12 with the minus 12. Multiply or distribute your 1/4 and do minus 3 with plus 3. And if both of them simplify to X, then you have proven that they are inverses of each other. So, not hard to do, but you need to make sure you know what to do without being told. We may not tell you to use composition of functions. We may not write the notation this way or this way to give you that kind of a push. Okay, question 3. There could be a lot of different answers here, but this guy, part A, says you want it to be a function. So that means whatever your answer is, to be a function, it has to pass the vertical line test. So if you drew something like this, that doesn't work because this does not pass the vertical line test. So you have to draw something that passes the vertical line test. So I usually just write down the first thing I think of. But this one also is not supposed to be 1-to-1. So to be 1-to-1, it has to pass the vertical and horizontal line test. Well, that works for this one because it doesn't pass the horizontal line test. So you obviously don't need the same graph, but your graph has to pass the vertical line test to be a function, and it has to fail the horizontal line test to not be 1-to-1. Over here, this one wants it to be a function, so this one should also pass the vertical line test. I'm going to try to get away with the same answer here. But he is supposed to be 1-to-1, which means he would pass both of these, and so this one does not work. The same graph doesn't work for A and B for me. So if anything, try not to get too complicated. Just make something easy. There's a line, passes the vertical and horizontal line test. That's plenty sufficient. But again, you do not need to change yours, but if you have any doubt if yours is correct or not, you can have me look at it here in a few minutes after we wrap this one up. Okay, question 4 wants us to find the inverse of this, and they're even giving us all the steps here, but we shouldn't expect the steps to be on the quiz. So to find an inverse, this is the first thing we did in the notes today, is switch X and Y, and then solve for Y. But this guy shouldn't be equal to Y, and this guy be equal to Y, because those are not the same thing. So instead of saying Y equals in the end, you should say the inverse of F. Okay, I didn't make this worksheet, so I don't really remember what the point of this one was, but if we use this and plug in a few points, we can find those values. I'm more interested in this piece because this is a pretty hard answer to get. So I tried to give you enough of a hint on your notes without completely giving it away. But this function up here, I could have stopped, and I didn't do it right away because I didn't know if I needed, but I could have thought about his domain and his range, because if I know the domain of this, that's going to become the range of the inverse function. And if I have the range of this, I know the domain of the inverse function, which is what they're asking for. So the domain was right here. They restricted the domain to be x can be equal to 0 or bigger than 0. I'm just writing in interval notation. You can leave it in inequality notation if you want to. But which means that I also know the range of the inverse, which is not what was asked, unfortunately, because that's the easier one. To get the range of this graph, there's not really a good algebraic way to know what the range is. I would just suggest graphing it. You should know what x squared looks like, shift it down 1, and then visualize the y values that it hits. Whatever the y values the function hits would be the x value that the inverse functions hit, and that would be one way to get that answer. A second way, just for you to have a backup and to check, is since you had to find the inverse anyway, you could have also graphed this. So ideally, you know what the square root of x looks like. That's considered a parent function too. And then the plus 1 would just shift it left 1 based on where the plus 1 is. And so I can see his domain is -1 to infinity, which verifies that. So 2 different ways to come out to the same answer. And I will ask for questions here at the end of it, so if you do have something in there, just hold off for a minute. Okay, question 5 is just like question 1, just slightly different notation here. If you're given 3 points on a function, switch their x's and the y's, and you've got 3 points on the inverse. And I'm going to skip number 6 for a second because I think it's the hardest, well, it's probably the most missed question. And let's go down to number 7. The graph of a function, to be a function, you have to pass the vertical line test. If the graph of a function passes the horizontal line test, then its inverse is also a function. If it passes both of those, we call it one-to-one. So mostly some vocab there. Vertical line test to make sure it's a function, horizontal line test to make sure its inverse is a function, and if it passes both, we usually call it one-to-one. Okay, so what makes question 6 kind of not tricky, but it just takes, it's not easy, like you just look at it, read it, and get your answer. You have to play with it a little bit. So when I look at this, I see that it's supposed to be a function, and the fact that it's a function means our final answer needs to pass the vertical line test. So whatever answer, I'd say probably the most common answer here is not possible, but this is possible. So whatever answer you have, it better pass the vertical line test. Also, his inverse function, he does not have an inverse function. So he has an inverse, but not an inverse function, which means that the horizontal line test has to fail. And it's got to be an odd function. So, odd functions, remember, are the ones that are symmetric to the origin. So something like x cubed is an odd function. Symmetric to the origin is like a 180-degree rotation. So whatever a function, whatever you think your odd function is, you should be able to turn your paper exactly upside down and it should still look the same. Whereas this is for odd. Whereas if it had said even, it would be symmetric to the y-axis. like x squared. X squared is an even function. So I have to think of something that's a function. It's got to be symmetric to the origin, and it can't pass the horizontal line test. So right away, I would say x cubed is pretty close. The only problem with x cubed is it does pass the horizontal line test, so that's not quite good enough. But I can still make something that's symmetric to the origin, passes the vertical line test, and not the horizontal line test. All you had to do was give this a little bit of a bump, so that with symmetry, you got a little bit of a bump there. Now it's got the right type of symmetry to be an odd function. It's a function because it passes the vertical line test, but its inverse is not a function because the one I came up with does not pass the horizontal line test. So for that question, you did have to remember about the symmetry for even and, well, for odd functions at least. And you had to probably play with it a few minutes. If you tried to get an answer in less than a minute, you probably gave up too fast. Okay, and then that's it. So we're not going for quantity here, definitely more of quality. So all of these things would be good things to ask you about on your quiz. So before I turn our screen off already for today, is there any of this you'd like to ask about or have me discuss again?
You just say number 5.
Yeah, number 5, you just have to switch x and y, just like question 1. Others?
On 4, do you just pick random points for the f of x?
Over here,
Yes, sir.
I just plugged these x values into f of x.
I got it.
So I plugged, I mean, I don't know why it asked for those, to be honest,
Okay.
but you can plug in 0, 1, and 2 and then find out what y is. So I just
Gotcha.
did it since it was on there. Okay, other questions? Okay, so when we came back from winter break, remember I gave you a little bit of a lecture about how most people think second semester is a little bit easier because it's mostly algebra stuff. But first we had to get law of sines, law of cosines out of the way. Then we had to get our limits unit out of the way. Pretty much the rest of the stuff we do the rest of the years is algebra review. So again, in theory, you should have seen all of this in Algebra 2. And so what we're hoping for is that you're just getting a reminder and highlighting the questions that you had forgotten about or the topics you had forgotten about. But I guess at the end, which can make it very easy and not a lot of work, but at the same time, if you never learned most of this or you forgot most of it, then you need to force yourself to put in a little bit of time for studying, because you do need to know this. And again, this does seem kind of out of place, but after our quiz on this on Wednesday, we will move on into exponentials, and we don't spend very long on exponential functions either. But then right after that, we move into logarithms, and we will do 3 sections of logarithms, so we go pretty in depth there. Whereas Algebra 2, you probably just saw an introduction, but logarithms are super important, also for science courses and stuff. But my guess is, at least when I used to teach Algebra 2, we only spent 2 weeks on logarithms. And even in here, we'll end up spending like probably 3 weeks. So we go more in depth and make sure that you understand it well. But the reason why we do it in that order is exponential functions are inverses to logarithms. So if you know what it means to be an inverse function from this section, it helps you kind of get some footing when we move into logarithms, because you will know about exponentials then. So that's kind of the thought process. Okay, if you guys do see anything else that you'd like to ask about, then please do. I think number 80 is the only one I'm taking up next time, and I believe that's already in Google Classroom. If you just want to turn it in and not have to worry about it. Let me double check though. Okay, it's not, but I'll do it right now. So give me just a second. And And of course, while all of that is fresh in your head, I highly recommend that you guys circle and highlight the questions and topics that you think you might need to review before our quiz. Okay, that is in Google Classroom now, so if you want to turn it in now so you don't have to worry about it on Wednesday, then that is an option. And if there's anything else I can help with, then please call me over or bring it up here to me. But that is it for today.